Picture this. You're standing in front of a line that's been down for 2 hours. Your boss is breathing down your neck, production is losing thousands by the minute, and everyone's looking at you to fix the network issue. The problem? You know PLCs and you know I/O, but when it comes to PROFINET, you're flying blind. I'm Alana, and after 3 decades of troubleshooting everything from simple relay logic to complex motion control systems, I can tell you this. PROFINET doesn't have to be the mystery that stops you cold. Let's fix that right now. So let's start with the obvious question. PROFINET is called Industrial Ethernet, but here's what that really means. Regular Ethernet, the stuff in your office, works great for sending emails and browsing the web, but try to control a high-speed packaging line with it, and you'll have chaos. The problem is timing. In the office, if your email takes an extra millisecond to send, who cares? But in automation, if a stop command to a servo motor is delayed by even a few milliseconds, you could have damaged product, broken machinery, or worse, safety issues. PROFINET solves this by taking Ethernet hardware, cables, connectors, and switches, but adding intelligent traffic management on top. Think of it like having express lanes on a highway. Your critical control traffic gets the fast lane, while your diagnostics and configuration data use the regular lanes. Every PROFINET system has exactly 3 types of players, and understanding these roles is absolutely critical. First, you've got your I/O controller. 99% of the time, this is your PLC. It's the brain that runs your control logic and coordinates everything else. Second are your I/O devices. These are your field devices, your I/O blocks, motor drives, sensors, and anything that interfaces with the real world. They're controlled by the I/O controller. And third is the I/O Supervisor. That's your engineering software running on a PC or laptop. This is what you use to configure everything, but here's the key point. It doesn't participate in the real-time control. You can unplug your laptop and the system keeps running perfectly. This separation is brilliant because it means you can do diagnostics and troubleshooting without affecting production. I can't tell you how many times this has saved me when tracking down issues on a live line. Now let's talk about how PROFINET actually achieves this real-time performance, because this is where it gets clever. Every Ethernet message has a little code called an EtherType that tells the receiving device what kind of data it's getting. Regular internet traffic uses one code, but PROFINET has its own special code, 0x8892. When a PROFINET device sees that code, instead of sending the message through all the slow processing layers like regular internet traffic, it takes a shortcut directly to the application. It's like having a VIP pass that skips all the lines. The result? Regular TCP/IP might take 10 or 100 milliseconds with unpredictable delays. PROFINET real-time can consistently deliver your control data in under a millisecond. That's the difference between smooth operation and disaster. Now for really demanding stuff like synchronized multi-axis robotics, there's an even faster version called IRT, Isochronous Real-Time. And the newest development is Conformance Class D, which uses TSN, time-sensitive networking. CCD achieves the same high performance as IRT, but uses standardized IEE technologies instead of proprietary hardware. The big advantage is that TSN enables truly converged networks, where your control traffic, IT data, and even video streams can all share the same infrastructure with guaranteed performance. These give you cycle times down to microseconds with virtually no jitter. But honestly, for 95% of what you'll encounter in the field, regular PROFINET RT handles everything you need. Alright, let's talk about actually commissioning a network, because this trips people up constantly. There are really just 3 steps, but you have to do them in order. Step 1. Build your project in the engineering software. You import the device description files, GSD files, for each device, then drag and drop your controller and all your devices into the project. Step 2 is critical. You assign each device a unique name. Not just an IP address, but an actual name like main conveyor drive or tank 1 level sensor. This name gets burned into the device and becomes its permanent identity. You also tell the controller what IP address each named device should get. But here's the key. The controller assigns these automatically during startup. Step 3. Download to your controller and watch the magic happen. The controller broadcasts "Who is main conveyor drive." The device with that name responds, gets its IP address assigned automatically, and boom, you're in business. This automatic discovery and addressing is one of PROFINET's best features. No more manually setting DIP switches or dealing with address conflicts. Let me save you some headaches by covering the mistakes I see most often. First, cabling. Yes, PROFINET uses Ethernet, but for the love of all that's holy, don't use office-grade Cat5 cable on the factory floor. You need industrial-rated shielded cable, usually with a green jacket. The EMI from motors and drives will absolutely destroy your communication if you don't. Second mistake, not understanding that switches matter. Most PROFINET devices have built-in switches, which is great, you can daisy chain them. But if you're using external switches, make sure they're managed switches that support quality of service. And the biggest gotcha of all, device names are case sensitive and must follow strict rules. No spaces, no special characters except hyphens and underscores, and they must be unique. I've seen experienced techs spend hours troubleshooting only to find they had motor 1, capital M in the software, but motor 1, lowercase, programmed in the device. Now let's talk about something that used to be an IT problem, but is now absolutely critical for every control professional. Security. Here's the brutal truth. Traditional PROFINET has zero built-in authentication. That means if someone gets access to your network, they can send fake commands to your devices or crash them entirely. And with more plants connecting their control networks to the corporate network or the internet for remote monitoring, this isn't theoretical anymore. The number one thing you must do is network segmentation. Your PROFINET network should be completely separated from your IT network by a properly configured firewall. Not just a switch, not just a different VLAN, a real firewall with strict rules. Physical security matters too. Lock your control cabinets, disable unused switch ports, and never leave a laptop plugged into your control network unattended. I've seen too many test connections become permanent backdoors. And here's what's available now. Newer PROFINET devices support security classes with signed configuration files and secure commissioning. When you're specifying new equipment, look for Security Class 1 certification. This is separate from the conformance classes we talked about earlier. Those define technical capabilities like CCA through CCD, while security classes define cybersecurity features. Both matter for modern systems. Remember, security is layers. Physical security, network segmentation, device hardening, and monitoring. No single measure is perfect, but together they make your system a much harder target. Here's your takeaway. PROFINET isn't magic, it's just smart engineering. It takes standard Ethernet and adds the intelligence needed for real-time control. Master those 3 device roles, understand the real-time shortcuts, follow the 3-step commissioning process, avoid those common cable and naming mistakes, and never ignore security. The reality is, once you understand these fundamentals, PROFINET becomes one of the most reliable and flexible networking technologies you can deploy. What's your biggest PROFINET challenge? Drop it in the comments below. I read every single one, and they often become future video topics. If this helped clarify things for you, hit that thumbs up and subscribe for more practical controls content. Until then, keep those systems running smooth.